Welcome to another unit in the workbook statistics. This time I'm going to talk about Spearman's rank correlation coefficient and the general idea behind rank correlation. Well, the problem is correlation coefficients, as we might know them, can only be calculated for metric data. But what if we only have ordinally scaled data, which can only be ordered, but there is no distance information given? Well, in this case, we can still apply Spearman. Spearman is not as powerful as the Pearson correlation or the Bravais-Pearson correlation, but it's like the best we can do if data only is ordinal. Well, in this case, we first start by ordering our data set from smallest to largest value, and then depends on what we're going to do next. Depends insofar whether our data points have ties or have no ties, because the next step would be the ranking procedure. Well, what is a tie with regard to ranking? Well, if we have the same value, they would theoretically be assigned the same rank, because we cannot say, well, which of two observations with the same value is smaller or larger. Well, let's start with the simple version. We have no ties. Every value is unique in its way. Then we can simply assign the value at position I, the value I, or the rank I. So the value at position 8 is value 8. Position 1 is value 1, and so forth. So that's relatively easy and straightforward. However, if we have ties, then it might become a bit more problematic, because then the assignment of these values is no longer a unique process. One version would be, well, we can assign each value the minimum rank. So for example, if two values would get rank 1 and 2, but they have the same value, then I say, well, they are rank 1 and 2, so they're both assigned rank 1. Minimum of the two possibilities. A better way to go about, also a bit more correcter way, would be taking the average of all possible outcomes. So again, same example, two values would share first and second rank. So the average of first and second would be 1.5. So both values would be assigned the value 1.5 for their rank. If, for example, the values 3, 4, and 5 would have the same values, then, well, we take the average of 3, 4, and 5, so the average would be 4. All three would be assigned the rank of 4. Well, that's about it on ranking data. As I said, the better version is working with this mean version. Once we have the rank data, the rest is relatively easy and straightforward, because in this case, we simply apply the formula for the Bravais-Pearson correlation coefficient to our ranked data. And also the interpretation is exactly the same. So it's a value between -1 and +1. 0 means there is no relation whatsoever. The closer the value gets, the coefficient gets to -1 or +1, the stronger the relation is, the correlation is. The more positive it is, the more of a positive relation it is, meaning large values go hand in hand with large values, small values go hand in hand with small values. If it's negative, this means it's a negative relation. Large values go hand in hand with small values go hand in hand with large values. Well, I said values. This, in this case, should be interpreted as ranks. So the rank with a positive relation, the rank of one observation is relatively high, then the rank of the other one would also be high. With a negative one, if the rank of one is low, the rank of the other variable would be high. Well, that's something you can always use, and you have to use if there are ties present. If there are no ties, we can use a slightly simplified version. So I would just have to take the difference in ranks from the variables, square this difference, sum it up, and then multiply with 6, divide by n, and in parentheses n squared minus 1, and the result is then subtracted from 1 or 100%. So that's very fast, very easy to calculate, but it only works if you do not have any ties present in your data. Well, that's more or less everything on Spearman's rank correlation coefficient. I want to give you one final comment. In the beginning I said that's particularly aimed at ordinal data. That's true, you can calculate this starting with ordinal data, but there's nothing keeping you from using this as well on metric data. So it can be done in the same way, and the advantage of using metric data is very rarely do you have any ties. However, as I said, it's not as strong as the Bravais-Pearson version, because the Bravais-Pearson version measures for linear relationship, whereas Spearman's version measures for a monotonous relation. What does monotonous relation mean? Monotonous relation simply means large, large, small, small, or if it's negative, small and large. Whereas linear means all the values would be situated on a straight line. So as long as it's just increasing in the relationship, or strictly decreasing in the relationship, it's monotonous. If it's increasing or decreasing in a linear fashion, then it's linear. Well, that's then the final comment with regard to Spearman's rank correlation. Hope you enjoyed this session. I say goodbye and see you next time.